In our next video, we're finding out how these things work. So remember in our last video, I said that electromagnetic waves are caused by accelerating charged particles. Well, we can create radio waves using a transmitter. So how this works, I've got my piece of rod here as an example. If I put my rod here, place a charge on this and cause the electrons inside my pole to move up and down, I've got moving charges. If I have moving charges, I'm creating an electromagnetic wave. This is exactly how radio stations produce their broadcast signal. They have their transmitter. Their transmitter is connected to a current of some description. This current causes the electrons in the transmitter to move up and down. As the electrons move up the transmitter, we get a high negative charge near the top. As the electrons then move down to the bottom, we get a high negative charge down the bottom. This moving negative charge of up and down produces the electromagnetic wave, which has the same frequency as these electrons moving up and down. If I have electrons moving up and down at this speed, I have the electromagnetic wave produced at the same frequency. If my electrons are moving up and down a bit faster, I have an electromagnetic wave which has a higher frequency. So, a transmitter uses an electric current to produce an electromagnetic wave by the movement of electrons up and down. Of course, that's only if we have a vertically opposed wave we want to produce. If we want to have a horizontal wave, we have to move our signal generator from up and down to side to side to get our electrons moving backwards and forwards like this. So signals are generated using a transmitter which has an electric current connected to it, causing electrons to move up and down. Okay, I mentioned before something about the oscillation or the frequency of the particle, creating the certain frequency of the wave. So let's look at an example here. I've got the old boombox out. If I turn it on, alright, this radio is currently receiving a signal at 104.7 megahertz. So, the signal being produced by the radio station is 104.7 megahertz in its frequency. The signal that's being received by the radio is exactly the same, 104.7 megahertz. The information this radio is receiving is on the frequency of 104.7 megahertz. If I change the frequency, alright, so I've changed the frequency. The radio is now receiving 98.7 megahertz. So 98.7 megahertz is what the radio is receiving. The radio station, which happens to be Power FM and Murray Bridge, is sending out the signal of 98.7 megahertz. So this antenna that we got on the radio, the electromagnetic wave from our radio stations is causing the electrons in this antenna to go up and down at the same frequency as what was being transmitted by the transmitter at the radio station. The same happens with television waves. However, televisions have a different orientation to the aerial. You notice that radio antennas are pointing up and down. Well, our television antennas are horizontal, if you notice and look on the roof. This is because the orientation of the transmitters are at different angles. Radios have their transmitters up and down in a vertical direction. Television has theirs horizontally. So the electrons are going backwards and forwards in that direction for a television. So the key points from this video. The electrons moving up and down the transmitter causes an electromagnetic wave of the same frequency as that of the electrons moving up and down. The radio signal is then transmitted to a receiver. In this case was a radio. That radio receives the signal when causing the electrons inside its antenna to move at the same frequency as that wave. The frequency is the same from the receiver and my antenna receiving the signal. Also, the orientation of the antenna is important. If I have waves up and down, I need to have an up and down aerial. If my waves are horizontal, I need to have a horizontal aerial. So, in our case, radio signals, TV signals. Okay, enjoy!